Artificial intelligence and quantum computing, two extremely sophisticated technologies that I will talk about in this segment. So this is actually part 2 of integrating artificial intelligence and a new technology today known as quantum computing. So here I am in my Research and Development Design Center in Medellin Software Valley. Medellin Metropolis is a very beautiful green avatar with an amazing thick natural forest, which has become my natural resource of inspiration in producing state-of-the-art quantum artificial intelligence design methodology. Okay, before I start, here are some challenges as it relates to both artificial intelligence and quantum computing. As you know by now, these two technologies have caused all levels of society a high degree of anxiety. Will these technologies cause the destruction of our planet? That is a typical question asked by most people around the world. Or will these technologies disrupt negatively our way of life? Or even perhaps, will artificial intelligence take control of planet Earth? The scope and framework of these projects is to expose the compelling facts in order to intellectually develop future generations of artificial intelligence in conjunction to quantum computing to augment and benefit humans on planet Earth. I am an engineer and have designed medium-sized engineering prototypes applying level 1 and level 2, that is low levels of artificial intelligence, in applications such as intelligent drones, autonomous cars, and cognitive robotic systems. So for all of you, you can actually view about 50 or more of my technology videos, which are uploaded and are available on YouTube under Corp Intel Tech, CORPINTELTEC, Corp Intel Tech. As an engineer, I apply rigorous safety precautions in the design methodologies in all engineering prototypes. Emphasis is made in assertions for fault-tolerant implementations as well as insertion of error correction and error detection in all of the different designs that I have been performed. So, software algorithms detail analysis is executed in providing comprehensive functional verification and universal verification methodology at the system level. Also, software and hardware emulation in conjunction to high-level simulation is performed in all engineering prototypes. The main objective of these rigorous tests is to ensure safety, and corrective action, preventing an eventual malfunction, thus applying protection to the end user. As I had mentioned before, Medellin's software is an extremely sophisticated first-class city. It offers its citizens excellent healthcare and the best public integrated metro transportation system in the world. Medellin is also the main technology epicenter for the fourth industrial revolution in planet Earth. It is also the best artificial intelligence hub in the world, integrating artificial intelligence in the metro system, which is 100% electric and digital. It is a digital system, as well as in its healthcare and clean hydroelectric energy generator, which supplies clean energy to several countries, including the country of Colombia and the city of Medellin as well. So, as you can observe, a significant amount of precautions in terms of implementing machine learning software, mathematical algorithms are used. There are specific quantum encryption predictive software models integrated within the artificial intelligence driven system, and sophisticated FIR filters are used. The objective is to detect any erroneous and to recognize all science data points in all of the millions of data servers on planet Earth containing misleading as well as detecting misinformation and disinformation, thereby rejecting all fake and all disrupting and destructful information from all databases on planet Earth. As I have illustrated in this video, it is of critical importance to continue and to advance in the research and development of both artificial intelligence and quantum computing. What would happen if the USA were to stop research and development in artificial intelligence? The ramifications would be disastrous for all of us in the free world. The answer is very simple. Whatever nation who ultimately achieves full implementation and achieves full deployment of quantum computing with artificial intelligence will rule and will dominate planet Earth economically, socially, politically, and militarily. In essence, the artificial intelligence will, or rather true artificial intelligence, will not be achieved for 200 to 300 years from today. So, in good practice, the engineering community will continue to make significant progress with artificial intelligence and quantum computing, solving challenging problems in curing cancer and all healthcare related terminal illnesses, resulting in prolonging life in a near future to perhaps 130 years of age. Let me reiterate, I am producing this workload from the Artificial Intelligence Design Center in the best and only technological epicenter for the fourth industrial revolution, together with Silicon Valley in California, USA. The design center, which I have produced the body of work, is actually in Medellin Software Valley, that is the best and most innovative city in the world.
Topics presented in this video include quantum computing, qubit arrays, entanglement, superposition, quantum qubit operations, how to measure quantum qubits, how to enable quantum qubit gates, future of quantum computing, machines fused with classical computers, quantum computing resonators, and a proposed quantum computing hybrid platform architecture with other digital platforms. So the behavior of quantum mechanics as it relates to subatomic particles explains the complex behavior of atoms. For instance, electrons can exist in multiple distinct states at the same time. This is known as superposition, and it's impossible to know for sure at any given instant what state an electron may be in, because the very act of observing the state, it changes. So subatomic particles can be entangled so that change to one influences an other. So my idea is to develop algorithms for optimization problems in data storage and energy efficient data retrieval, with applications in autonomous vehicle systems and autonomous robots, with some influences on artificial intelligence. Therefore, in quantum computing, quantum logic gates are represented by unitary matrices. The most common quantum gate operates on spaces of 1 or 2 qubits. So, as matrices, quantum gates can be described by 2 to the n times 2 to the n sized unitary matrices, where n is the number of qubits that the gate acts on. The variables that the gates act upon, the quantum states, are vectors in 2 to the n complex dimensions, where n is once again is the number of qubits of the variable. So the base vectors are the possible outcomes if measured, and a quantum state is a linear combination of these different outcomes. Therefore, my work in quantum computing related applications, I will be exploring those applications in communications, distributed navigation, and system diagnostics. That includes cryptography, software debugging, and machine learning capabilities. Okay, let's bring quantum power computing into proper perspective. For instance, a 3-qubit computer runs 8 options in parallel. Therefore, a 5 or 6-qubit quantum computer, this system will run 32 or 64 options in parallel. We can continue to increment. 30-qubit quantum computer runs as many options as the ones stored in 134 megabytes. And scaling the qubit quantum computer to 50 qubits, we're talking about 300 terabytes of information. So we're reaching the quantum supremacy, and it is totally amazing with a phenomenal computation capability. So it is important to note that the next generation of computing system will encapsulate the quantum computing technologies with that of classical computers, thus creating a phenomenal symbiosis of computers of the quantum magnitude collaborating seamlessly in a hybrid platform to become a very powerful computing machine. So, quantum computing architectures and technologies. The quantum gates are performed and enabled by sending electromagnetic pulses at microwave frequencies to the qubits. Electromagnetic pulses have a duration, frequency, and phase which determines the angle of rotation of the qubit state. For instance, for a single qubit operations, only one pulse type needs to be calibrated. However, in a 2-qubit gate, tuning is required to calibrate the interaction between the 2 qubits by driving the control qubit with a microwave pulse tuned at the frequency of the target of the second qubit. Once the qubit operations are completed, you can measure the qubits by sending a microwave tone to their resonators. In superposition mode, a qubit can be more than one thing at a time through quantum mechanics, which is a principle called superposition. Thus, given quantum computers, their speed and parallelism enable them to work on millions of computations at a time. So when qubits are linked with other qubits, they are in a entanglement mode. That is, a state of one qubit can depend upon the state of another qubit. When entanglement combined with superposition, the quantum computers have the phenomenal potential to simultaneously process a vast number of computations. Therefore, the numbers that describe the amplitudes for different possibilities define kinematics, the space of different states. The dynamics describes how these numbers change with time. For a particle that can be in any one of infinitely many discrete positions, a particle on a lattice, the superposition principle tells you how to make the state.
Quantum qubit architectures and hybrid autonomous platforms. Here is an illustration of a fusion of quantum qubit architectures with a hybrid data flow technology, yielding a sophisticated, intelligent autonomous platforms used in intelligent drones and intelligent autonomous robotics.
The main objective is to concatenate quantum computing as a paradigm by fusing artificial intelligence in deep cognitive machine learning. In addition, my goal is to integrate cloud computing and multi-agent system software models in order to create mathematical algorithms and software models with applications in smart drones and intelligent robotic systems and platforms.